So this is another acronym we are going to add to the list. I know I have this document called the map of the calendar, which summarizes a lot of key points. And we've done IVT, MVT, EVT, AROC, maybe a couple other ones. Now this is AVOF, okay? Average value of function, okay? Average value of function. Now, the procedure is actually really easy. Let's talk about the concept real quick. The concept is actually pretty easy too, but when it was taught to me back in the days, the concept was glossed over, and I knew how to do the procedures, but I was like, what is this about? And I don't want that to happen to you guys. So here's the concept, okay? We got a function, and we have the area underneath the curve, okay? And there is, let's say the area is 20. Okay, I made it up. There is some rectangle, okay? There's some rectangle. Is it here, where the point of intersection is there? Is it here, or is it here, or anywhere else? And here's a point of intersection for that one. There's some kind of rectangle where the area of the rectangle, in this case light blue, is going to equal to the light gray, okay? All right, that is the key visual I want to implant, okay, in your head, okay? Now, what we're usually after is, what is the x and y coordinate of the point of intersection of the rectangle and the function itself? Again, where the rectangle area and the area under the function and the x-axis bounded by the function x-axis is the same. So we're looking for the x and the y coordinate of that point of intersection, in this case the green dot. More specifically, we're after the y coordinate, okay? More commonly, okay? So would you agree, let's say that this is, I'm gonna make up a number. Let's say this is 9. Let's say this is 2, okay? Would you agree that the length of this rectangle is 7, which is 9 minus 2? Okay. All right. Now let's say the height is 4, okay? Would you agree that the area would be 28 in this case? All right. So 28 would be the area of the blue rectangle, which in this case would be the same as the gray area bounded between the function and curve in this hypothetical case. We good? So it'll be 28 here, it'll be 28 here and 28 there. Okay? All right. Now, if we want to find the y value, okay, so Stephen and everyone else, if we want to find the y value, don't you basically multiply both sides by 1 over 9 minus 2? Yeah? Which is basically 1 over 7. Does that make sense? Okay, if you want to find the y coordinate. Okay, this y coordinate is the average value of the function. The y coordinate of the point of intersection between rectangle and function is the average value of the function. Okay, so this would be the y coordinate, which in this case would be 4. Okay, does that make sense, folks? Okay, all right, now let's say this is 3. Let's say this is 2 and that is 7. Okay, now let's go like 2 and 5. Now, would you agree that conversationally speaking, if I were to say, what's the average value between 2 and 5, wouldn't you do 2 plus 5, divide that by 2, and you get 3.5? Yeah. Conversationally speaking, that's correct. However, when you say the average value of a function, you do not simply do 2 plus 5, divide that by 2. That's conversationally what you would do. Calculus-wise, you would need to do this thing right here, okay? Which in this case, you would find the area of the gray, okay, and multiply it by 1 over 9 minus 2, which would give you the y coordinate, which is 4, okay? All right. Okay, so we're after the y coordinate, long story short. Now, let's actually go through an example here. Okay, so let's get some highlights out the way. Now, and let's go like, let's see if I can go like this. Boom. Okay. Okay. Now, what is the average value of the height of the function? Okay, blah, blah, blah. Okay, so let's start here. Green. This is the same as this, which gets plugged in here. Does that make sense? Okay. Now, this is your A and B, A and B, A and B, A and B, A and B. We good? Okay. Now, remember I told you we want to isolate for y? So I'm going to do 1 over b minus a. Okay? So this, okay, let me do a triangle. This is basically this. Okay? All right? And now we just evaluate it, okay? So now, okay, now we're going to take the antiderivative, which is this right here, okay? And then we're going to plug in what? 16, and then subtract it from plugging in 0. Remember we did that before break? Antiderivatives with some upper lower bounds. Okay, plug in the upper bound, subtract it with plugging in the lower bound. Okay, and then we get 1, and then this simplifies to basically 16. Okay, now, so 16 is the y coordinate. Okay, is the y coordinate. All right, so we found the y coordinate. Okay. Now, this right here, what is the value? When you read this, this is a classic example of a lot of words for a very simple question. Okay. When they ask this question on the AP exam, out of 10 kids, 4 out of 10 test takers, 4 students off the top of my head will miss this simply because they don't understand what it's asking for. All this means is find the x coordinate. That's it. Find the x coordinate, aka the question mark. Okay? So what we do simply is take this and set it equal to this. That's it. Okay? We set this equal to the y, set the original function equal to the y coordinate and solve backwards for the x coordinate, which they use C for the letter. Does that make sense? Okay? And you just solve backwards, yada, yada, yada. And you get 7.11 years. Okay? Next example and last one. Okay? Same idea. Okay? I'm going to go through this a little faster. Here we go. Now, green, green, green. Okay? Pink, upper lower bound, upper lower bound, upper lower bound. We good? Okay? Remember, this cancels, we're after the y value, 1 over b minus a. Okay? Sorry for the crappy looking a. Here, let me try to do it better. All right? So 1 over b minus a, this pink triangle is that. Okay? And now we just do algebra. Antiderivative, boom. Plug in, okay? Plug in upper bound, and you get that. Plug in lower bound, gray, and you get that. And then you multiply that by 1/2, and you get 14 over 3. Okay, algebra. Okay, so now that's the which coordinate again, folks? Y coordinate. Now this is asking for, the bottom is asking for the x coordinate. So you literally just set this equal to this and solve backwards for x. Okay, all right. Let's see if I have that copy and paste it somewhere. Yep, so this equals to that. What they did is multiply everything by 3 and subtract 14 from both sides to get this quadratic formula. 2 answers. This one doesn't matter because it's not in the interval. Okay, it's not in the interval. Okay, that's today's lesson, folks.